Okay, so you see the screen here, but then also see I'm projecting in class. So keep that going, just seeing my masked face here. Okay, all right, so start by taking it down, and then I'll just blabber during this. Okay, so, and then I'll start talking about the notes after that, but I have a new calendar. Some of us have already done that. So at the bottom of our calendar that's going right now, it just ends, and then it says link to new calendar. So hit that link, going to the next calendar, which I call the quarter 4 calendar, even though we don't have quarters here. Just a better web page, right? When you're back up to the top, instead of having to scroll down, that's makes it more useful. So that's why I cut it into quarters so that we can go back to that. Um, Last week is still on there though, because that was the start of chapter 5, which is all we really need. But those other calendars still exist, and you can always find them on. I think I always put them on Google Classroom, and I probably should put the fourth quarter one on there. So there's another way of finding it. But unbookmark the quarter 3 calendar and bookmark the quarter 4 calendar. That calendar is closed, the quarter 3 one. But go into that real quick. Sorry to interrupt you, but I'm going to go to this. You'll see my email for a flash. That's not your calendar, this one. Oh, actually, that's the other one. I got to move myself. Just going here. Well, actually, I don't have to. I don't have to describe what that calendar is, but this is what you're going to be turning in, you know, along with today's. So those 3, you're going to give them to me. I'm going to stamp them and hopefully give them back to you. And then when we take the actual closure test of this chapter, you're going to return in those stamps for me to record it. Because I like making sure you're doing it daily, because that's the only way math works. I don't care what anyone says. We don't, I'll do my homework in a month. Well, you're already way behind. All right. And that's what's happened to so many people that have not done their work. All right. And that's how math is. And there's no two ways about it. I think science is very similar. So we're going to keep those going. And if you don't have them that day, they're late, right? And you can turn it in the next day and I'll probably take a point off. And then after that, it's over. I'm not waiting forever for your homework. It's not how things work. It isn't. So make sure you know that. And that quiz will be super short. Somebody in here knows that, right? And it's not really that bad. So um, actually, let me do this before I re-show these notes. Here is, I'll even give you more information. Here's 15 points of that quiz. No two ways about it. All right, just having those memorized right there. There's 15 points of it. And then there's 5 more points of a matching. All right, so there's no confusion here. Everyone should at least get a 15 out of 20 if you miss the whole matching. And if you don't, it's actually on you. I'm telling you have to memorize those formulas from 5-1. All right, so let's get to this. And actually, if you do have your worksheet from the last before break, if you do, you can just look at it yourself, pull that out. Because we have a little difference today. Nobody has that worksheet? It's okay, I'm not collecting it. But that worksheet from before break, I want to make sure you can still be heard here. There were no equal signs. It just said simplify, and you were arbitrarily just supposed to change things in terms of sine and cosine, maybe use a Pythagorean identity to make things smaller, and then maybe things cancel, and then you had to guess what your answer was at the end. Is that the end? And a lot of times it does get pretty small, and it's pretty obvious. Now look at the sheet that you picked up. Look at it right now, the sheet you picked up today. What's the difference? What do all of these have that none of the others had ever? Starts with an E. Say it. An equal. And these are not lies. These are all true. The directions say verify. So guess what? You have the answer right here. All right? The problem is you need to show the work in order to verify structurally through what you've already done to prove one side equals the other. So there's the difference. You will not have any that look like this on Thursday or Friday. You guys are Friday, sorry. But the matching section is very similar. Like you have to simplify, then you have to pick what answer matches what you have, and it directs you where you have to go. So it's very close. So that's why I wanted to keep it a little bit simple on the verifying identities today, so that it does kind of mirror what I'm expecting you to do on Friday. Okay, so here's your process for verifying an identity. which means there is an equal sign, which means you know the answer. Okay, first of all, sine cosine stuff, for sure. Oh, that's number 2, or number 3. But whenever you see either side of a fundamental, the other side should come to mind. Also be aware of equivalent forms of the Pythagorean identities. Go ahead and write that down. You already should have during my blabbering time. But of course, sine squared plus cosine squared equals 1. So if I subtract cosine squared, then sine squared equals 1 minus cosine squared. All right, so be aware of those alternate identities. So what does, a real quick question in this one, come on, pen. We know we're going to be fighting the pen, right? There's nothing I can do about it. I just can't get this thing to be efficient for me here. What is cosine squared of theta minus 1 equal? I switched them. What does that actually equal to then? Is it equal to sine squared, yes or no? Now it looks like I had to multiply this by -1, so I multiplied both sides by -1. This is negative sine squared. So be careful on that. That's another alternative form of these identities that I actually ask a lot and have you, make sure you know that. Okay, number 2, this is important. It's not try. Do or do not. There is no try, Yoda. You will pick one side on this sheet. You will pick one side and simplify that side until it exactly equals the other. You will never mess with both sides. And that is a rule that you must stick with when you're verifying an identity. And it must be structured. And I want it, sadly, I asked all my classes yesterday, how many people have done a geometry proof? Raise your hand. And actually, I've had nobody raise their hand. Have you? Freshman year? Nice. Okay. Geometry proof is they give you some information and they say, prove this. Well, that's the answer. And that's the last step, the proof of what you're supposed to be proving. And then there's a reason for it. But all the stuff in between is the logic that proves this last thing, right? Okay, well, that's what this is. It's almost like a geometric proof. I'm not going to have you write reasons, though. I'm not going to be mean about that. All I need is logical structure, one change to the next, using the 5-1 identities. So yes, these have to be memorized, like I've said from the beginning. And then we got to keep that structure, which I'm going to help you with today. So what do you have in front of you right now? This is actually your notes and your homework. I'm going to do 6 of these. You have to do the other 6. Got it? So go ahead and take that out. I just thought in the world that we live in right now, I thought it'd be a good idea to approach this way. So that when you go home to do your homework, you have your work in class, and then you can, equate that to some of the other questions, what structure should look like. So I'm going to start, actually, I hope you can see number 1 is actually pretty easy, but we'll see as I go through this. But I'm going to start with number 2. And then here's the structure, and this must be emulated, all right? And I know what the other math teachers are doing. They are doing a step and then writing to the right a reason. And I don't want that. I can read your logic. I don't need the reason, all right? So first of all, what side do you think looks slightly more complicated, the left or the right? What do you think? The left, it's got one more operation, right? It's got a sine squared. So that's really what you want to do. You usually want to work with the more complicated side to try to make it equal to the other side. And I'll show you how the structure works. Before you do anything, though, you want to think a little bit. Like, what's tangent? Don't write it. Think it. What is tangent? Blank over blank. Now I'm just going to leave this to open responses since it's been a full break. But what's tangent? Blank over blank. Sine over. Okay. All right. Now, so this is how you think. This is equal to sine over cosine. Ooh, all right. Oh, I have a cosine on the bottom. Okay, I think I know where to go. So here's step 1. Step 1 is I'm going to show my teacher that I know sine squared is sine times sine. And I think you really should show that before we show anything else. And then equals. Okay, this is where I'm going to be nice. Not really nice. I think it's logical. Just draw a line. Yeah, I'm trying to get it equal to that side. Don't keep writing the right side. We understand what we're trying to do, but keep looking at it. All right, did you hear everyone? What is this equal to that I'm highlighting in yellow? What is that equal to? Tangent. And it actually does end up going like this. And then why do I have a 2 there? Because that's step 2 of my, oops, sorry, always put an angle measure there. That's step 2 of my proof. All right, and then he knows that's how proofs. He had numbers for proof, step 1, step 2, step 3. All right, if you never did a geometric proof, then you're just going to have to follow the structure. And I do want it, I'm sorry if I didn't give you enough room on this worksheet, but whenever it's on a piece of paper, your steps go straight down. All right, they go in rows like this. All right, and then what's the relationship between sine and cosecant? Sine equals, everyone, 1 over cosecant. So guess what? You could write this in one more step, or if you want to write it like this, fine. And why would I do that? Because I'm looking at the right side. That was step 1. Step 1 in the notes I had up there, always look at the right side to try to get this to match. Try to get these things to happen. So I don't think you really needed step 3. You could have written this as step 4 right away. Remember what I told you? Sine in the top is a cosecant in the bottom. So technically, you don't need that step written there. But I don't blame you if you do. I mean, it's nice. You don't really need that step though. So there are some things, some people will go a little bit quicker than others. Okay? And actually, technically, if someone skips step 1, I guess it'd be okay, but you can't be skipping a whole bunch of steps because that's, yeah, in a geometric proof, you just say, hey, yeah, it's true. Well, no crap. I know it's true. It's a proof, right? You got to have the logic to show that it's, you must show the work to prove it. So we need those steps there. Okay, now this is where it gets weird. I like the worksheet from Thursday, Friday. You guys Friday before break. Hey, what's nice about looking at the new calendar too? We see the end. All right, and it's all in one page. I'm like, oh my gosh, that's all I have to do. I have to just get to here. And actually, we're probably going to stop a week early for those that are doing your work, of course, and are doing excellent. So you may even be done a week early. I think our last test is the week before the 3 days, and then we'll spend those 3 days trying to get the others that need to catch up, I guess. But what's weird about these is this isn't necessarily simplify anymore. This is a game. This is like a math game of trying to get things to match up. Right? So this is weird. And if I ask which side looks more complicated, there is no answer, right? Don't they look identically like the same amount of stuff going on? Correct? Okay. So one thing I told you last week, let's just say last week. Let's forget about spring break for a minute. Whenever I see a squared, what should I look for? Which of the identities? Come on, someone say it. Pythagorean, not the sine cosine stuff. All right, that sometimes gets to be a little rough. Now I'm going to pick the right side because I know my formulas, and then everyone should be watching this because this is going to solidify maybe these Pythagorean identities. This is why I picked the right instead of the left. You're fine for picking the left, by the way. What I love about these is I'll get different answers from students, and they'll be correct, right? Because it's not only one way to do this. But why would I pick this? Who knows their Pythagorean identities? What's secant squared? 1 plus tangent squared. And there's nothing we can do for you, folks. Only you can memorize it. No one can memorize it for you. See what I did here? And I knew this was the approach. So I'm going to put my step 1 over here. Or did I finish that and draw an arrow? Oh, I didn't. Let's go back up to here. Sorry, my bad, dogs. Ruff. See, I don't ever want you to have to rewrite the right side. Just say, check, I nailed it, got it. All right? So that's how I want that structure, and it'll be perfect. Okay, so I'm sorry, I just realized in my head I did not, write that final step there. But I know, I'm sitting here looking at this and going, okay, this is weird, but I know secant squared is 1 plus tangent squared. And I have a tangent squared over here, so I know I'm getting somewhere. That's why it's a game. It's like a little matching game or whatever. Okay, then what's cosecant squared? 1 plus cotangent squared. Only one student. All right, fine, long break. You got some work to do by Friday. And then notice, okay, now the right side, it's like variables. The right side has the same variables as the left side. This will be a match. I bet you this will be a match after I do some math. And the math that you have to do next is distribute. Now notice I put parentheses. This is a big mistake. Big mistake not putting parentheses around here, because one of the big mistakes in math is not distributing a minus sign. It is huge. Okay, so do not skip steps. Write this all out. And then actually you're going to find out we could actually be done. Because what happens to the ones? And I accidentally leaked into the next question, but I'm not doing the next question. So what happens to the ones, everybody? They cancel. Do I have to rewrite this? No. That says tangent squared minus cotangent squared, and that's what the left side says. So check baby, 1, 2, 3, I'm done. 2 steps, guys. 2 steps. On the quiz for the matching on Friday, 1 to 2 steps, I think, at most. And you should be able to match something. Careful, though. There are some little tricksters in there. Okay, so look at 6. Very much like 4. I actually used the worksheet generator, and I felt like this was good. Just kind of keeping it simple still after we come back from break, and really helping you on what I'm going to, test you on Friday. Okay. Ooh, who looks more complicated? Come on, this is straight easy. Which one's more complicated, left or right? Fractions are always more complicated, right? And it's easier to go more complicated to simple, right? So that's what we want to do. We want to work with the left side. And then here's what you want to do in this. What do you know about secant? Secant is 1 over what? You don't get the answer. You're answering all the questions. There we go. Who said that over there? Nice. So the left side has secant. The right side has cosine. Let's try to turn the left side into cosines. And by definition, secant is 1 over cosine. Now, there's 2 ways we can go about doing this. I'm going to do a little bit longer way first. Okay, get ready. What operation is that? Division. What does it mean to divide by 1 over cosine? Multiply by the reciprocal. So step 2, this would say cosine. You can either write it on the left or the right. Times 1 plus 1 over cosine. Oh, and then sorry, I got a little sloppy. Equals. That also denotes I'm on a second step, along with my number 2 there. And then when you distribute, it's over, because we should know that cosine times 1 is cosine. And then what's cosine times 1 over cosine, everybody? 1. And then look at the left side. I'm sorry, look at the right side. My left-right's all switched up. Boom shakalaka. Oh, don't worry about commutative property. Cosine of x plus 1 is equal to 1 plus cosine of x. 2 plus 3 equals 3 plus 2. That's the commutative property of math. I have another way of doing this. You ready? Okay, you leave this. Don't just put your pencil down. Okay. Oh man, they slammed it down. All right. I'm going to erase this middle step and show you how we end up getting right to this when I go back up here. This is a mathematical structure that we might need in the future. I actually can take a fraction and multiply the numerator and denominator by the same thing, and it's still the same value. I didn't change its value. What do you think I'm going to multiply top and bottom by? I'll give you a hint. It's a trig thing. The trig thing that you see there. What's the trig thing that you see there? Someone say that. Cosine, thank you. So I'm going to multiply top and bottom by cosine of x, because you know what cosine of x over cosine of x equals? The number 1. You just multiply that by 1. All you did is change the way it looks. Oh, then look. Cosine plus 1, fine, over 1. But I know that equals the right side. Now I did that in 2 steps, not 3. So it's one or the other, right? And that's just to prove that there's different ways you can approach these and still get the same thing. Alrighty then. Which one did I do yesterday? Oh, look at 7 and look at 8. Very similar structure. Ooh, cosine to the 4th, though? Interesting. So I do like that one a little bit. All right, so now I look at number 7. Flip it over. We're moving right along. We got 25, right? 1125. Okay, hopefully my voice, as I keep turning from the microphone, so I better stop doing that, I guess, and more focus on the screen over here. But who looks slightly more complicated? Left or right? Left. There's a plus sign. I mean, come on. And then what did I tell you about squareds? What should we really look for when we have squareds? Pythagorean. If we start doing the sine cosine thing, sometimes that makes it worse. So I would, with squareds, check if Pythagorean helps me out here. Okay? So we already said it. I'm not knocking her out because she already has it memorized. Someone else tell me what 1 plus tangent squared is. Secant. And I should have went back up here. I'm sorry. My bad, dogs. Riff. Looking at this again, I want you to solidify these Pythagorean identities with the other ones. Look at how secant squared is 1 plus tangent squared, non-cos. And then look at how cosecant squared equals 1 plus cotangent squared. So the initial trigonometric identity for Pythagoras, I just said that really weird. I tried to save my sentence there. It's always 1 plus tan or cotan squared. And if it's 1 plus tangent squared, that equals secant squared, non-co. 1 plus cotangent squared equals cosecant squared. Very good mnemonic device to remember. If that's not really a mnemonic device, but a device to memorize. So 1 plus tangent squared equals secant squared. All right, we got to start rolling with this memorization. Now, you could actually be done in one more step. If you remember what I said before break, a secant squared on the top means a blank on the bottom. Fill in the blank. Cosine squared. A sine squared on the bottom means a what on the top? Cosecant squared. So you quite literally could write number 2, and notice how these all work out. I would want my students to write this. This logically tells me that they know that idea. And then, okay, yes. And these always end with something equal to itself. You never touch the other side. And the other side that you're working with always ends up being the other side. That's why I'm really checking the middle, right? To make sure that we got some stuff there. Okay, if that was too quick, then you'd have to do this. What is secant squared? Secant squared is 1 over, come on. All right, now tell your counterparts and hear everyone else. And if you still don't have these memorized, that is completely, totally on your shoulders. And then what's sine squared? Because we see the other side. 1 over, right? Make sure you don't forget that. So now this is adding some steps, but this proves why a sine squared on the bottom is a cosecant squared on the top. Because yet again, this is division. And dividing by this means multiplying by the reciprocal. And then that turns into the other side. So that's fine. That explains the fractional work of this. And there was only one thing that really kind of simplified it. The rest of it was a game of trying to match the other side correctly. So sometimes they get weird. Sometimes you have to go a little bigger instead of smaller to match the other side. Instead of simplifying. I think that's awfully familiar to the other one. Very similar scenario. Maybe a couple extra steps there because I see the right side. Probably, I think on this one you probably go either or, but I think I'd deal with the left side. Actually, now that I think about it, I'd probably go to the right side. Try and get those squares that happen. So I think I might go to the right side on that one. That one's an interesting one. But I'm going to go to this one. Okay, so I'll do 10 with you and then one more after this. And we're at 11:14, so we're doing well. I hope my sound works. This microphone better be good. Worth the money I paid for it. Ooh, I think it's arbitrary which side's more complicated. I think some people might think the right side is more complicated because there's a plus sign. But I have two trig things on the left, so this is an either or. All right, and on a test coming up like next week or the following, I forget where we have it managed. I think it is the end of next week, like Friday, when we're all together. Um, I would get I get a bunch of different answers. Some working on the left, some working on the right, and that's how these work. All the examples yesterday, I worked with the left because I thought a little bit. I thought a little bit about first of all, what did I think last week? I just know what I want to do, but and I think some of the classes I did something a little different both times. But what's the cosecant squared Pythagorean identity? So 1 plus what equals cosecant squared? Cotangent squared. If I think about this, what's cosecant squared on the top? What does that mean it's on the bottom? Okay, so cosecant squared on the top means what on the bottom? So what I'm doing is what you should be doing. Before you start writing and start doing steps, you should start thinking. Okay, hold on. This is a weird one. But if I look at the left side, this can turn into cosine squared over sine squared. What's cosine squared over sine squared? What's cosine squared over sine squared? Cotangent squared. Now I have the bridge. All right. And I know cotangent squared shares cosecant squared in a Pythagorean identity. I'm getting somewhere. So that's what I'm going to do. I'm going to stick with this side, and I'm going to turn this into step 1. You got to really make this like this, though, negative parentheses. Because once things start changing, you got to be careful. And I think I'll write this out. I'll add an extra step. But I will tell you, those that are really, good with this, you could skip step 1 and go right to step 2. A cosecant squared on the top means a sine squared on the bottom. I really, really, really want like everyone to be able to do that fast and then reduce a step. Okay, now again, it's about the proof. So you are going to tell me that you know that this is cotangent squared. And then again, in me doing this, yay, my pen stopped working. See how it's getting all like scratchy? So you have to tell me these things. There's no skipping steps, right? Okay, then how do I get cotangent squared equal to cosecant squared, that negative plus 1? Well, first of all, remember that it's 1 plus cotangent squared equals cosecant squared. So what does cotangent squared equal to? What do I simply have to do with this identity? To get cotangent squared by itself, what do I have to do? Subtract what? 1. So that's that alternative form of the identity. Yay. Wait for the pen, wait for the pen. There we go. Love you. So this is cosecant squared of x minus 1. And then when you distribute the negative, then you get negative cosecant squared plus 1. And I think that's exactly what's written on the right side. So even though like right around step 3, you should have been like, all right, I got it. I got cotangent squared. I'll use a Pythagorean identity because that's what they have in common. But then it takes a couple more steps just to prove it. I could have done a whole bunch of other different things. I'll tell you what I did in the first 2 periods yesterday. I actually changed this to 1 minus sine squared. And then I distributed a cosecant squared. Actually, I got done in 2 steps, if you can think about that. When I changed this to 1 minus 1 minus sine squared and distributed, I ended up getting parentheses negative cosecant squared minus 1, and then I distributed the negative. So I got it done in 3 steps. I could have went to the right side. I could have factored out a negative 1, and then that's what that negative's on the outside, and that's a negative cotangent squared. But then it's hard to turn that into this. It really is. It's a little bit different, but it would work. So way different ways you could do these. And then at the end, we have these that seem to be a little similar. I do like that number 12 for you guys to take home with you. So I'll do number 11. Who probably looks more complicated? Left or right? I think fraction's always more complicated, right? And then just think though before you begin. Just don't write it though. But what's one plus cotangent squared? Just to give you a thought. What's one plus cotangent squared? Cosecant squared. So if I can get this to be cosecant squared, then I just have one more step, right? And that's how you direct your thought process. So let me hope I can get cosecant squared out of this by doing some stuff. What do you think you're going to do with the left side? What's the number one process that really hasn't happened that much today? Maybe not multiply by the reciprocal because whatever you do to one side, say it. Never do that in identity. You can never do two things. You're not balancing equations. You can only work with one side to turn it into the other. So that would not work. So what's our first go-to that I haven't really used a lot today? Turn everything into in terms of sine and cosine. Who said that? Nice. Okay, so good. Thanks for the. You're much more talkative than the other fifth hour. Ugh. They all look like they want to kill me when I do the notes. I don't know what I've done to them. I'm waiting for the pen to activate. Yay! Thanks, pen. Maybe I'll start writing with it. There we go. So what's cotangent? Come on, we've did this a lot today. Cotangent is what? And if you don't know that, that is on you, and you're gonna screw up that first 15 points on the quiz. Only you can help. Only you can memorize. No one can help you. You can't memorize these identities. It's on your shoulders. I'm just telling you that right now. Every single person should get a 15 out of 20 minimum. All right. Oh no, that didn't really get me very far. Well, don't do nothing. Do something. What did we say over and over again? This operation. What is it? It's well, no. What operation is that line? Division. And there are no squared, so we have no Pythagorean identity going on right now. But that's a division. So I'm going to rewrite this as divided by sine cosine is multiplied by 1 over sine cosine. So I want to write that like that. And this is fractions 101. This is why I said this is not, when we do these identities, it's usually not the identities, although I always have every year students that just cannot memorize. Nothing I can do for you. But also, it's the fractions and the idea of working with fractions and how they work. Oh, I'm excited because first of all, who cancels? Oh, no, who cancels? Cosine. I have a cosine over a cosine. And then you don't have to write that as 1 over sine squared. I know that's 1 over sine squared. What is 1 over sine squared? Cosecant squared. And now you're like, all right, I got it. That's what I was looking at the right side. That was my objective. I wanted this to get to cosine or cosecant squared. Sorry, I might have said cosine squared on accident. So I meant cosecant squared. And then, of course, through a Pythagorean identity, it is equal to 1 plus cotangent squared of x equals. Now, I'm not ripping on the other math teachers. The other math teachers have you write reasons over here why you do each steps. I have never wanted my students to do that just because as long as your logic is there, as long as I see a structured step by step, sure, the student knows cotangents, cosine over sine. Sure, the student knows dividing by means flip multiply. Sure, the student knows canceling and knows that's, all this is logically replaced one step at a time. I don't need any reasoning. All right, and I hope you understand that and appreciate that because I think that's all we really need to be doing. All right, do the other 6, and then that will be turned in along with the other 2 assignments Friday for you. Thursday for my Monday crew.